Geometry Unit 4 Review Packet video. So we've broken down into 3 videos, with each video corresponding to 2 pages from the review packet. Starting with number 1, it's actually a little bit easier to understand number 1 if you look at number 2 first. They're both asking about perpendicular bisectors. Number 2 says, which diagram shows the construction of the perpendicular bisector of segment AB? In order to construct a perpendicular bisector, we need to create 2 points which will allow us to draw that bisector. Of A, B, C, and D, only A has 2 points that we could use to draw that perpendicular bisector. B doesn't have any. C has these, but that's not going to give you a perpendicular bisector, and D only has 1. When we draw a perpendicular or construct a perpendicular bisector, we place the compass at one end of the segment and the drawing part of the compass slightly more than halfway. Then we draw an arc and flip it around and do the same thing from the other side. And that's why A would be the correct answer here. Going back to number 1, these 2 x's on top and bottom are what allowed us to draw that perpendicular bisector. So the construction marks that we would need would be these 2, 1 and 3, which gives us the answer of B. Number 3, which illustration shows the correct construction of an angle bisector? Of A, B, C, and D, A doesn't show or doesn't have any way to have made this x to draw our line through it. C doesn't have any x at all for which to draw our line. D has no construction marks at all, and B has the arc that we needed in order to make the x that came afterwards. B would be the correct construction of an angle bisector. Number 4, based on the construction below, which statement must be true? This is the construction of an angle bisector, the same as in number 3. Here's the arc that we used in order to draw the x later on. If this is an angle bisector, it means that these 2 angles must be equal to each other. So ABD and CBD have to be congruent. Looking at our answer choices, we see a couple with halves in there, which we're not interested in because we have congruent angles. ABD to ABC, ABD, that's the whole distance. And here we have ABD and CBD, which would be the bottom angle. These would have to be congruent because an angle bisector splits an angle into 2 equal halves. For 5, 6, and 7, we have to use the distance formula in order to find the length of the sides to classify each of these triangles as equilateral, isosceles, or scalene. Equilateral meaning all the sides are the same, isosceles meaning 2 are the same, and scalene, none. We'll save 5 so we can look at a shortcut if you have a coordinate plane, and we're going to look at 6 and 7 first. For 6 and 7, I'm going to have to use the distance formula with each pair of sides. So AB, BC, and then AC. To find the distance between A and B, our distance formula was the square root of x2 minus x1 squared plus y2 minus y1 squared. And all of this underneath the square root. So for AB, x2 minus x1 would be negative 6 minus 0 squared. Put a little note here, AB, plus y2 minus y1, 0 minus 0 squared. And then we can simplify. Negative 6 minus 0 would be negative 6. 0 minus 0 is 0. Squared would still be 0. And then we can square this. Negative 6 times negative 6 would be 36. And 36 plus 0 would be 6. So that tells us that the length of segment AB is 6. Next we'll look at segment BC. So I have x2 minus x1. So this would be the square root of negative 3 minus negative 6 and 2 minus 0. Here we've got a double negative, which actually means that this is going to become negative 3 plus 6. Negative 3 plus 6 would be 3. And 2 squared, and all of this still underneath that square root. Finally, we need to simplify. 3 squared would be 9, 2 squared would be 4, so this would be the square root of 9 plus 4, 13. If you like, you can turn this into a decimal. However, it's not necessary. We're just trying to compare the square roots to see if the roots are the same size. So if we end up with a root 13 for the last side, or 6 for the last side, we know we'll have isosceles. At this point, we know that our triangle is not equilateral. For the last one, we need to do AC. So for AC, we'll plug everything into our formula. So negative 3 minus 0, 2 minus 0, squared, squared. Negative 3 minus 0 would be negative 3. 2 minus 0 would be 2. And at this point, negative 3 squared and 3 squared are going to give us the same thing, 2 and 2. This is going to have to be the same as BC. So negative 3 squared would be 9 plus 4. This is square root of 13. So because two sides of this thing were the same, we can label this as isosceles. Moving on to 7. We'll go a little quicker this time. So from my first pair of sides, subtract the x's, subtract the y's, and all that underneath a root. So negative 2 minus 4 would be negative 6, squared would be 36. 3 minus 5 would be negative 2, squared would be positive 4. 36 plus 4 would be square root of 40. So AB is root 40. Next we'll do BC. 0 minus 2. Oh, sorry, 0 minus negative 2. Negative 1 minus 3. I'll just put a little square root sign to show that everything here is underneath the root. Cleaning up, 0 minus negative 2 would be 0 plus 2, and then 2 squared would be 4. Negative 1 minus 3 would be negative 4. Negative 4 squared would be 16. So this would be square root of 20. We know our triangle cannot be equilateral. For the last side, we'll have to see if it's going to be isosceles or scalene. So for AC, 0 minus 4, negative 1 minus 5. So 0 minus 4 would be negative 4. Negative 4 squared would be 16. Negative 1 minus 5 would be negative 6. Negative 6 squared would be 36. Now at this point, I really don't need to go any further. I have sides of square root of 40, square root of 20. When I add these two numbers together, I am not going to get either 40 or 20, which means that my sides cannot be the same. This is scalene. Since we've already done the distance formula on two of these problems, I'll show you a small shortcut you can use if you have a coordinate plane when you're finding the distance. You could look at each of these and write down the coordinates. So we could say that x is at 4, 2, y 2, negative 2, and z is negative 2, 0. However, there is an easier way to do this. I can just take each segment and look at its slope, essentially. This thing goes up 4 units and over 2 units. This segment would go up 2 units, 1, 2, 3, 4, 5, 6, and over 6 units. And finally, this down here would go over 1, 2, 3, 4, and down 2. Notice how these two have the exact same slopes. 4 and 2, 4 and 2. That means that the length of these segments is going to be the same. The third segment is totally different, 2 and 6. So we can say that this would be isosceles, because 2 of the sides are the same and the third one is not. You could go through and use the distance formula, however, this is just a little bit quicker. For number 8, 9, and 10, we'll use the fact that every triangle must add up to 180 degrees. So the right angle means this one is 90, so that lets me write the equation. 60 plus 90 plus, we'll just call our unknown angle x, has to be equal to 180. 60 and 90 would be 150. Subtract that 150 on both sides, and that's going to give us x equals 30. Number 9. All the angles have to add up to 180 in a triangle, so x plus 44 plus 80 plus 60 equals 180. If we combine our three like terms here, 80 and 60 would be 140, plus 44 would be 184. Subtract that 184, and that gives us x equals -4. Now we have a negative value as an answer. We're not allowed to have negative angles, so we need to check to make sure that that doesn't cause this angle to be negative. If I were to plug in this -4, this angle would still be positive. -4 plus 44 would be positive 40. So even though we have a negative answer, that's okay because it doesn't allow us, or doesn't cause us to get a negative angle. Finally, number 10. All three have to add up to 180, so 76 plus 57 plus 4x plus 3 equals 180. If we combine our like terms, 76, 57, and 3 would give us 136. Subtract the 136 on both sides, and that'll give us 44, and then divide by 4, 11. 11C. When you have an exterior angle, which is just an angle created outside a triangle by continuing on a side, the exterior angle is always equal to the sum of the two opposite interiors. So that means that these two added together has to equal that exterior angle. So 115 equals, we'll call this x. Subtract 60 and get 55. Number 12, same idea. Two opposite interiors equals exterior. We call this x again. X plus 33 equals 79. Subtract that 33. And get 46. 13. This one looks a little more complex, but it's still the same idea. Two opposite interiors equals exterior. 42 plus 4x minus 6 equals 9x minus 4. I'm going to do two steps at once. I'm going to subtract the 4x on both sides. And I'm also going to do 42 minus 6, just to simplify that side a little bit. To get x by itself, we'll add that 4. And last, divide by 5. And that gives us 8 as our value of x. 11D, ordering triangles, sides or angles by size. It says, list of sides of the following triangle from least to greatest. We know that the smaller the angle, the smaller the side that it creates. And the side that an angle creates is always opposite of it in a triangle. Here, 42 is the smallest angle, and the side opposite of that would be EF. The next smallest angle is 67, and the side opposite 67 would be EG. And finally, 71 is the largest angle, which is opposite of FG. So our order should be EF, EG, and then GF. So we have EF, EF, EG, or GE because they're the same, and then finally FG. So our correct answer would be A. Number 15, order the sides of triangle LMN from shortest to longest. So same idea, small angle, small side. So my shortest side would be LM. Next, we would have the angle of 64, which is opposite MN, followed by LN.